Welcome to Olympiad Primer. Today in this video, I teach you a very important topic. That is important topics in mathematics, Olympiad mathematics, the number theory. Actually, to solve the Diophantine equation like 1 by x plus 1 by y equal to 1 by a natural number. It is very important type of Diophantine equation, frequently asked Olympiad question on this topic. So especially for the learner students, those who are interested to learn how to solve this Diophantine equation and Olympiad mathematics number theory, they will be very much interested, I think. Actually, today in this video, I would discuss about 3 problems that are asked in Indian Regional Mathematical Olympiad in the year 1992, and one of them is Indian Olympiad Qualifier Exam 2021. What is more interesting is actually the way in which a learner student, a schoolboy, a schoolgirl can understand and learn how to solve this Diophantine equation, as well as they can learn the whole concept, and they can learn how to raise the proper order of arguments of prime factorization, how to manipulate an algebraic form, how to rearrange so that factorization is very much easy, and by factorization they can reach the way in which it will be very much easy for them to guess the value that the variables can take. So actually not only solution of a few problems, a few Olympiad problems, this is not great thing, but I want the schoolboy or schoolgirl, the school students can learn how to solve the Olympiad number theory problem related to this special type of Diophantine equation, that is 1 by x plus 1 by y equal to 1 by a natural number. But they can have a clear idea, a clear concept about the prime factorization. For example, if the product of 2 prime numbers is equal to a square number, then every prime numbers will be a square number. It is very, very important ideology and theory. By applying this ideology and theory, there are several problems and questions will be solved. So the learner student must learn this theory and must learn to understand this theory. And if I think a junior student can learn this, I think any junior student can learn this ideology, and if he learns this ideology, they can easily solve any tricky question related to this Diophantine equation that are frequently asked in the Olympiad number theory challenging problem. So I think today's video will be very interesting to those who are studying in class 8 or 9. They can easily understand and they can easily learn how to solve this Diophantine equation, all integer solution of this equation, as well as they can easily tackle by themselves to solve any tricky question on Olympiad mathematics. And before ending this video, I also I have discussed a very tricky geometry problem, and I think this will help you a very good lesson so that you can solve any tricky geometric problem like this. So no more talk, let us go to the today's problem. Now, today's first problem is find all sets of positive integers x, y which satisfies 1 by x plus 1 by y equal to 1 by 6. And the second problem is given that a, b, c are positive integers with no common factors such that 1 by a plus 1 by b equal to 1 by c, we have to prove that a plus b is a square. The problem is Regional Mathematical Olympiad 1992, the Indian Regional Mathematical Olympiad in the year 1992. And today's third problem, the most tricky problem, is positive integers a, b, c satisfy ab by a minus b equal to c. What is the largest possible value of a plus b plus c and not exceeding 99? This problem is asked in Indian Olympiad Qualifier Exam in the year 2021. So the problem is very much important, and all these three problems are related with the common Diophantine type of equation, that is 1 by x plus 1 by y equal to 1 by a natural number. So from this today's video, the very junior learner students, those you can well understand and learn how to solve the Diophantine equation like 1 by x plus 1 by y equal to 1 by a natural number, and how to solve all positive and negative sets of the value of x, y. So now let us first of all let us try to solve the first question, that is find all sets of positive integers x, y which satisfies 1 by x plus 1 by y equal to 1 by 6. We have to find out the values of x, y, all sets of values, because here satisfying this equation x, y have many sets of values, and we have to find out all sets of positive values, positive natural numbers that x and y can take, satisfying this equation. So now we can just rewrite this equation. So here, students, you should learn how to rearrange the given equation. First, x plus y by xy equal to 1 by 6, then xy equal to 6x plus 6y. It is very much easy, but you have to see that how the algebraic manipulation is to be done so as to factorize the algebraic expression, and by just factorization, the concept of factorization, we can go for the finding the value of xy. Just see, xy minus 6x minus 6y equal to 0, and then just look at here x is common for the first from the first two terms, that is xy minus 6x. If we can take x as the common, then y minus 6 will be a factor, and then next there is minus 6y, and next there is none. So you have to just think about this, that we have to factorize the total expression, that is xy minus 6x minus 6y equal to 0, so that the from the factorized form we can easily find and take the value of x and y. So we have to factorize this form. So to factorize this form, what do you think? What should you do? Xy here xy minus 6x minus 6y equal to 0. So you have to just put a 6 into 6, isn't it? Because if you take x as the common, then y minus 6 will be the term, and then from minus 6y, and then what will be the next term, so that by taking common, the next term, that is y minus 6 will come. So to get another y minus 6 from the third and fourth, we have to take a term, that is, you think about 6 into 6. If we have 6 into 6 in the fourth term, then we can easily take common 6, and then y minus 6 will come, isn't it? So we take plus 6 into 6 of both sides, like this, that is minus 6y, and then plus 6 square. Yes, plus 6 into 6, that is 6 square. And so easily we can take the common and factorize it. Y minus 6 will be the common factor from the algebraic expression attached with xy, isn't it? So here we can easily factorize. Just you see how y minus 6 will be taken as the common factor here. So here easily we find x minus 6 into y minus 6 equal to 6 square. This is the factorized form of the given equation, and from this factorized form we can easily find out the value of x and y, because here x minus 6 and y minus 6, the product of x minus 6 and y minus 6 is equal to 6 square. So here 6 square will give the complementary complementary factors of x minus 6 into y minus 6, and from the complementary factors we can easily get the value of x minus 6 and y minus 6, and from that is x minus 6 we can easily get the value x, and from y minus 6 we can easily value y. We can easily get the value of y. So in this way we can easily get the value of x and y. So here see clearly it is we can see that x minus 6 and y minus 6 gives the complementary pair of factors of 6 square. So just we have to find out, at first we have to find out the all factors of 6 square, the all divisors of 6 square. So how many divisors are there in 6 square? 36 needs to be expressed as the product of two factors, for that will be equal to x minus 6 into y minus 6. So if we can express 6 square as the pair of two factors, then we can easily get the value of x minus 6 and y minus 6, and from them we can easily get the value x minus 6, x and y. This is our strategy. Okay, so now first 6 square, the divisors of 6 square is also 36 itself. 36 is itself is also a divisor of 36, isn't it? So first from the greater to lower value of the divisors we can write that 36 is the divisor of 36, and next another divisor is 18, because 18 into 2 equal to 36. So 18 is also another divisor of 36. Then comes 12, because 3 into 12 is 36, so 12 is also a divisor. And then 9 is also a divisor, because 4 into 9 equal to 36, so 9 is also a divisor. So in this way 6 is another divisor, 6 into 6. So 4 is also a divisor. So in this way 3 is a divisor, 2, and also 1 can be taken as the divisor. So all these are the various divisors of 36. There are 9 sets of divisors of 36. So from this 9 divisors we can form the complementary pair of factors to be equal to x minus 6 into y minus 6. How do we form this pair? So let us see here pairs of complementary factors. First of all, we can take the first pair as 1 into 36. Then also we can take the second pair, that is 2 into 18, and next we can write 3 into 12, and then 4 into 9, another pair. So in this way we can take all the pairs of 6 square to be equal to x minus 6 into y minus 6, and reversely we can have the another pairs, that is 9 into 4, 12 into 3, and 18 into 2, and then 36 into 1. So in this way we can write the various pair of complementary factors of 36 so that they can be equal to x minus 6 into y minus 6. Now see, there are 9 positive pairs. So for the 9 positive pairs we can it is clear that we can have 9 pairs of value, that is x and y. For x and y we can get the 9 pairs of value for x and y. So now let us see how can we get the value. X minus 6 into y minus 6 equal to, first we can take the first pair, that is 1 into 36. So here x minus 6 equal to 1 and y minus 6 equal to 1, isn't it? And there from them we can easily get the value of x, because x minus 6 equal to 1, so x equal to 1 plus 6, so x equal to 7. And here also y minus 6 equal to 36, so y equal to 36 plus 6 equal to 42. So we can get the value of both x and y, x equal to 7 and y equal to 42. So one set we have got one set of value of x and y, that is 7 and 42 for the first pair of the factors of 36, that is 1 into 36. But there are 9 positive pairs. So all the positive natural numbers that x and y can take we have to find, and that all are the values of x and y, and we have to find out all these, and those are the answers of this problem. So for the first pair, that is 1 into 36, we have got the value of x and y as 7 into 7 and 42. And for the second pair, that is 2 into 18, we'll also get another set of value of x and y, that is x minus 6 equal to 2 and y minus 6 equal to 18, because x minus 6 into y minus 6 equal to 2 into 18. From them we have got x minus 6 equal to 2 and y minus 6 equal to 18, and from them we easily get the value of x as x equal to 6 plus 2, that is 8, and y equal to 6 plus 18, that is 24. So the value of xy, the another set of value of xy will be 8 and 24 for the second pair, 2 into 18. And also for the third pair, that is 3 into 12. So 3 into 12 will give another value of x and y, like the same way, that is x minus 3 equal to 3 and y minus 6 equal to 12. x minus 6 equal to 3 and y minus 6 equal to 12, and therefore the value of x and y will be x equal to 6 plus 3, that is 9, and y equal to 6 plus 12, that is 18. So the value of x and y will be 9 and 18. These are also the another set of value of x and y. And for the next pair of factors, that is for 4 into 9, we can get another value of x and y, that is x minus 6 equal to 4 and y minus 6 equal to 9. So in the same way, we can get another value of x equal to 10 and value of y equal to 15. And for the next pair, that is 6 into 6, also in the same way, we can have the value of x and y, that is x equal to 12 and y equal to 12. And for the next pair of factor, that is 9 into 4, also we will get another set of value of x and y. X equal to here 9 plus 6, that is 15, and y equal to 6 plus 4, that is 10. And for the next pair, that is 12 into 3, also we will get another set of values of x and y, like x equal to 12 plus 6, that is 18, and y equal to 3 plus 6, that is 9. So 18 and 9 will be the another values of x and y. So all these values of x and y will be the values of x and y from this from this given equation. For the next pair of value, that is 18 into 2, we also will get another value of x and y, that is 24 and 8. And next, for the last positive pair of factors, that is 36 into 1, x, the value of x will be 42 and y equal to 7, because 6 plus 36 equal to 42 and 6 plus 1 equal to 7. So all the pairs of factors of 36, we can have several values of x and y. Now we can write down all the pairs for all the values of xy for all the pairs of 36. That is for first pair, that is 1 into 36, we have got the value of xy as 7 into 7 and 42 as the value of x and y respectively. And for the next pair, 2 into 18, we have got the value of xy as 8 and 24 of x and y. And for the other sets, that is for the other pairs of factors, the values of xy will be respectively 9 and 18, then 10, 15, and then 12, 12, and then the values of xy will be like this: 15, 10, and then 18, 9. So all these are the 9 sets of values we have got. So these will be the total solution of the problem, the 9 sets of values. Now let us come to the second question. Just see that from the previous elementary problem, how we can approach and solve the second problem. The second problem is given that a, b, c are positive integers with no common factors, such that 1 by a plus 1 by b equal to 1 by c. You have to prove that a plus b is a square. The problem is not very hard, it is very easy, but to some extent it is tricky, and you have to know the actual arguments of factorization. So, okay, now let us tackle the challenging problem. Here, the equation is 1 by a plus 1 by b equal to 1 by c. So the equation can be rewritten like this: a plus b by ab equal to 1 by c, and by cross multiplication we get ab equal to ca plus cb. And the next step is nothing but we can take all the algebraic expression attached with ab in the left side of the equation, and right side is 0. So now we have to just rearrange and manipulate the algebraic expression in the left side so that we can factorize. This is our strategy. Okay, so see here what happens. Here you have to just look that AB minus CA minus CB, there are these three terms. So the fourth term, what will be the fourth term, so that we can easily factorize with that fourth terms. And if we can put plus b square of both sides, then easily we can take the b minus c as the common factor, because the first and second term, if we can take a as the common, then b minus c will be the factor. So the third and fourth term, from the third and fourth term, so b minus c will have to come. So that is why from this concept we come to the decision that b square will be the next, that is the fourth term. So we will take b square in both sides. Sorry, here c square will be the fourth term, because the c square, only for c square we can take the common c, and therefore b minus c will be the common factor, because there are cb. So b square will be the not correct form, that will be c square will be the correct form, so that is c square, and therefore we have taken c square of both sides. And now it is easy to common from the first two terms, as a is common, and b minus c will be the first factor, and secondly by taking c as common, b minus c will be the common factor, and therefore is equal to c square, the right side, and therefore easily we can factorize as b minus c into a minus c. Yes, so a minus c into b minus c will be the factorized form of the given equation in the left side, and in the right side there is c square. And now you have to come to the just the argument of factorization. Here see, a minus c and b minus c, the product of a minus c and b minus c will be equal to a square number, that is c square. So clearly it is understood that a minus c and b minus c will give a sharing factor, isn't it? and that is why a minus c and b minus c are a pair of complementary factors of c square. We know it, and therefore suppose a minus c and b minus c share a prime factor p. So for two factors, that is a minus c and b minus c, so p square will be the divisor of c square. So then p square is a divisor of c square, and so it is from this it can be said that p will be the divisor of c, isn't it? P will be the divisor of c, and from this decision we can come to the decision that p will be also the divisor of b as well as a, because b minus c and a minus c will be the two complementary factors of c, and since p is a factor and or divisor of c, so p will be the divisor of a minus c and b minus c. So what happened, that p is a divisor of c as well as b and a, but the given question, consider the given question, which is impossible because the given question stated that a b c, just see, a b c uh, will have the values as positive integers but with no common factor. So a b c will have no common factor, but here we see that p is a common factor or common divisor of a b c, so it is contradictory, and therefore only it is possible only a minus c and b minus c must be coprime, isn't it? So we have to take a minus c and b minus c as coprime factor. So we can come to the decision that a and b are already coprime, because a minus c and b minus c is coprime, that is a and b are coprime. So a minus c and b minus c, since a minus c and b minus c are coprime, therefore here we see that product of two factors, that is a minus c and b minus c, so actually here a minus c and b minus c will be the coprime, not a and b. So a minus c and b minus c uh, are coprime, and the product of two coprime factor is equal to c square. So it is very much important, students, you should remember that if the product of two coprime number, the product of two prime number is equal to a square number, then every prime number, that is a minus c and b minus c, will be the square number. So it follows from this that a minus c and b minus c will be, each of a minus c and b minus c, each term will be a square number. Understand? Here a and b are not coprime, it is as mentioned here defective, and we have to take that a minus c and b minus c are coprime, and therefore a minus c and b minus c are each of a minus c and b minus c will be a square number. So a minus c and b minus c are coprime, since the product of the coprime numbers is a square, so a minus c and b minus c will be a square. Every prime number, that is a minus c and b minus c, will be a square. So suppose a minus c is a square number, and we can suppose it that a square number like u square. So we can suppose a minus c is equal to a square number, that is u square. So we can just write this, let a is equal to 2 square, and then a minus c into b minus c equal to c square. So b minus c equal to c square by a minus c, that is c square by u square. So b minus c equal to c square by u square, and from this we can take the value a and b, and then we can add a and b, because in the given question it is asked that show that a plus b will be square. So now we can take the value of a and value of b, and then we can add, and we can see whether the value of a plus b will be a square form number or not. Now let us see for the value of a. Just from the first equation, that is a minus c equal to u square, we can take the value a. So a equal to, changing the side of minus c from left to right, we can get the value of a, that is u square plus c, u square plus c, and similarly b equal to c square by u square plus c, and then just add a and b, and we get the value of a plus b, that is a plus b equal to u square plus c from a, and from b c square by u square plus c. So a plus b equal to u square plus c square by u square plus c, and c, so plus c we can add this 2c, so we can write u square plus 2c plus c square by u square. So we have got the value of a plus b as u square plus 2c plus c square by u square. Now if we observe this expression, the value of a plus b, that is u square plus 2c plus c square by u square, so we can easily understand that this right hand side, that is u square plus 2c plus c square by u square, can easily be written as a square, because it is written completely and clearly in the square form. Because if we take u as the first term and c by u is the second term, then first term plus second term whole square we can take it, because u square plus 2 into u into c by u, that is cancelling u, so we can get 2c. So here 2c means 2 into u into c by u, and plus then c by u whole square. So u plus c by u whole square, we can write this. So we can write u plus c by u whole square, and it is previously stated that u is a divisor of c, because u is a divisor of a minus c. A minus c is u square, so u is a divisor of a minus c, and a minus c gives a common factor to u. So to c, sorry, so to c, so c by u is an integer. So clearly u plus c by u is a positive integer, and so u plus c by u whole square will be a square of an integer. So now today's the second problem is solved, and it is proved that a plus b is a square. The positive integers a, b, c satisfy ab by a minus b equal to c. What is the largest possible value of a plus b plus c not exceeding 99? So this is the problem. The problem is clearly stated that you have to find the value of a, b, c, so that a plus b plus c will be a value not exceeding 99. That is actually we have to find out the value of a plus b plus c, the maximum value of a plus b plus c up to 99. That we have to find out. So let us tackle this problem. This problem is asked in the Indian Olympiad Qualifier Exam 2021. So the problem is very tricky but not very hard. Let us see. The equation here is AB upon A minus B equal to C. So here the equation of the problem is appearing to some extent different from the previous ones, because the previous problem there is 1 by 1 by, but now it is AB divided by A minus B equal to C. But the expression can be rewritten as the same, and here the equation can be rewritten as just multiplication, cross multiplication, and we get the value CA minus CB equal to AB. And here also we can go for the same strategy, that is what will be our rearrangement of the expression. The algebraic manipulation will be accordingly, so that we can factorize the algebraic expression of the given equation. Here CA minus CB, so if we can change the side of AB, then it will be like CA minus CB minus AB equal to 0. And then here are three terms, so we have to get a factorized form. So there must be either 4 or 6 terms. It is easily understood. So we must get a term, isn't it? So what will be the fourth term, so that we can get the common? So here what will be the next term? The next term will be b square, isn't it? The next term will be b square. So b square comes, we can take plus b square in both sides, and then we can easily factorize. Just see here, from the first two terms, if we can get common, we can take common c, we can get a minus b as the factor, and also the third and fourth. From the third and fourth, there are b is the common. So, and a minus b will be the factor. So a minus b, after taking a minus b as the common factor, we can get c minus b, and in this way c minus b into a minus b equal to b square. We have got it. Now c minus b into a minus b equal to b square. So we can see that c minus b and a minus b is the complementary factors of b square. So c minus b and b minus b gives a common sharing factor of b square. And in the same way, we can have the argument like the previous problem. that is c minus b and a minus b are a pair of complementary factors of b square, and so here c minus b and a minus b must share a common factor, and suppose this common factor is k, because we have to guess the value of c, a and b both, isn't it? And therefore that is why just we can suppose the value of the common factor that uh, that that's shared by c minus b and a minus b for the b square is k. So k is the common factor of both b, a and c, because here c minus b and a minus b will be a sharing, will give the sharing factor of b square. So c and a also have the sharing factor, likewise, and therefore b and a and c, all these three variables will have a common factor, that is k. So suppose c equal to lk, a equal to mk and b equal to nk. For a suitable advantage, we can just guess the value of c, a, b, because here the all values of all the three terms c, a and b, there are a common factor k, so we can guess the value as CAB as LK and MK and NK. But if we observe the equation C minus B and A minus B equal to B square, then we can understand that C is greater than A and B, and A is greater than B, because A minus B is a positive factor and C minus B is also another positive factor, because in the right side there is b square. So clearly, just considering all these, we can uh, write this, that c greater than a greater than b. So clearly lk greater than uh, mk greater than nk, so nk will be the least, and then mk and then lk. So since k is their common, so we can write clearly from this that L greater than M greater than N, because k is everywhere, so we can write this by cancelling k in this equation. We can write L greater than M greater than N. Now since we have to guess the value a, b, c, so that sum of the values of a, b, c, that is a plus b plus c, will be a maximum up to 99. Suppose we can take the value of a, b, c, so that a plus b plus c, suppose a plus b plus c will be equal to 99 if possible. Suppose, if not, then less than 99. So first of all, we can guess that uh, adding the three values of a, b, c, that is a plus b plus c, will come 99. We can suppose it if possible, isn't it? So suppose, if possible, the values of a plus b plus c, that is lk plus mk plus nk, is equal to 99 if possible, because up to 99 the sum of their values, that is lk, that is a plus b plus c, will be up to 99. So first we can take this value as 99 if possible. So let us see. So we can consider all the given condition, that is a c minus b to a minus b equal to b square, and here we can also we have got the relation, that is L greater than M greater than N, and also Lk plus Mk plus Nk equal to 99. So now let us see that Lk plus Mk plus Nk equal to 99. Since if it is possible, then it means L plus M plus N into K equal to 11 into 9. We can write it, and just we can take that if K takes the value 9, then L plus M plus N will take the value 11, and therefore L plus M plus N equal to 11. And so considering all the situation, all the condition, all the equations, that is c minus b into a minus b equal to b square. So here c minus, just we now consider c minus b into a minus b equal to b square. Yes, c minus b into a minus b equal to b square. That means if we put the value of c, b and a like Lk, Mk and Nk in the equation c minus b into a minus b equal to b square, then we get L minus n into m minus n equal to n square, because taking k as common of both sides, left side and right side, we can write this equation like this: L minus n into m minus n is equal to n square. So we can guess the value of L, m and n, so that L minus n into m minus n equal to n square. It satisfies this equation, and it satisfies also the criteria that L plus m plus n equal to 11. So what will be the value of L, m and n? We have to guess the value of L, m and n. So it is clearly by guessing we can come to the decision that it is only possible if L equal to 6, m equal to 3 and n equal to 2, then only these three equation, that is L greater than m greater than n and L plus m plus n equals 11 and L minus n into m minus n equal to n square, satisfy. All these three equations satisfy. So see here, L minus n into m minus n, that means 6 minus 2 into 3 minus 2, that is 4 into 1. So the left hand side of L minus n into m minus n equal to 4 into 1, that is 4, and the right side, that is n square, will be the 2 square, that is 4. So it satisfies for L equal to 6, m equal to 3 and n equal to 2, and also L plus m plus n, that is 6 plus 3 plus 2, that is 11. So for the values of L, m and n, that is 6, 3 and 2, the equations, all these conditions and equations, that is L plus m plus n into k equal to 11 into 9, satisfied, and L minus n into m minus n equal to n square, satisfied. So it is clear that the maximum value of a plus b plus c, we have taken the maximum value of a plus b plus c equal to 99, and so it is also possible, because for L equal to 6, m equal to 3 and n equal to 2, we get the value of C, A and B like this, that is C equal to 6 into 9, because L equal to LK. So here L equal to 6, so K is working for 9, so C equal to 6 into 9 and A equal to 3 into 9 and B equal to 2 into 9. So clearly C equal to 54, A equal to 27 and b equal to 18. So clearly a plus b plus c will be 27 plus 18 plus 54 equal to 99. So 99, the uh, sum of a plus b plus a and b and c, that is a plus b plus c, will be equal to 99. It is the correct answer. So these will be the answer of the third challenging problem. So I think you can well understand this problem. So the problem is not very hard, but you have to reach the uh, values of a, b and c. So in this way, so then you can only reach the value of a, b, c and the value of a plus b plus c. So this is the answer. And so today's video, that is all. So now if you get interest for more such interesting number theory problem, Olympiad number theory problem, subscribe my channel and like my channel. And if you have any doubt, please mention in my comment section. And now also uh, we face a very tricky geometry problem. The problem is how we can obtain the area. We can obtain the value of the area of the shaded area of the geometrical figure as seen here. The resource of the question is a Mathematical Olympiad program of class 9 level, uh, the mathematics talent exam conducted by Indian Statistical Institute. So students, for your uh, advantage, just I am trying to solve this tricky geometric problem. Here are two half circle are drawn in between a rectangle of sides 5 centimeter and 10 centimeter into 10 centimeter. So now how can we find the area of the shaded portion of the geometric figure? Now we can just copy it here, paste, and next just see, we have to draw a portion that is here. Okay. Yes. So not, yes, and then yes, and just see a thin portion is here, that is I think H, and here A, P, and here B. This is B, this is A, and this is P. So here ABP is a triangle, and here it is easy to prove that AP and PB and AB all are 5 very easily, because here see PA is actually the circle, the radius of the circle, because here by pointing the center of A, here the half circle is gone through P. So AP is the radius of the circle, that is 5 centimeter, and BP is also the radius of the circle in the another side, pointing out the B as the its center. So BP is also the radius of the circle. Uh, so BP is also 5 centimeter, and AP is also 5 centimeter, and AB is also 5 centimeter according to the question. That is the breadth of the rectangle. So all sides of the triangle ABP is same. So equilateral triangle, and from equilateral triangle having side 5 centimeter each, we can easily area of ABP equal to very easy, root 3 by 4 into 1 side square equal to root 3 by 4 into 25, and again area of this whole, that is the whole thing, that is BPA with this circle portion, that is BPA, the part of the circle, like this. BPA, this area equal to along with the circle AP, the BPA's area of BPA equal to so here, since BPA a right angle, a equilateral triangle, so every angle will be 60 degree, isn't it? 60 degree, and so 60 degree angle uh, will form an area of a circle, uh, that is half circle, 1 by 3 of a half circle, isn't it? 1 by 3 of a half circle, that is uh, 1 by 3 of pi r square, means 5 square, by 2. So that will be the area of BAP portion of the circle. So it is equal to 25 pi by 6. So the thin portion H, the area of H equal to, we have to subtract the triangle from this uh, portion, area portion of the circle, that is ABP and triangle ABP minus the triangle ABP. That means 25 pi by 6 minus 25 root 3 by 4. So this is the area of the thin portion, that is H, and so the whole area of the shaded portion will be, we can easily find out, that is the 2 times of the triangle ABP plus 4 times of the H, that is 2 into triangle, area of the triangle is here 25
root 3 by 4. 25 root 3 by 4. 25 root 3 by 4. And plus 4 into this portion, that is 25 pi by 6 minus 25 3 by 4. So that will be equal to here 2 and 4 2, that is 25 root 3 by 2 plus here 4 into 6, 4 by 6, that is 2, 25 pi minus 4 into 4, 25 by root 3, 25 root 3. So clearly 25 root 3 by 2 plus 50 pi divided by 3 minus 25 root 3. So 25 root 3 and 25 root 3 by 2 togetherly, we can easily 25 root 3 by 2 minus 25 root 3 by 1 plus 50 pi by 3. So here clearly 25 root 3 by 2 minus plus 50 pi by 3. That means 50 pi by 3 minus 25 root 3 by 2. That is the answer of the given area. So the given portion area of the shaded area will be equal to this. So this is the today's fourth problem, that is a tricky geometry problem. So thank you all students. For more such tricky problem, subscribe my channel, and if you have interest for more such interesting Olympiad problem and talent question, you subscribe my channel and like, and also don't forget to comment in my comment section, and also if you have any doubt or query, please mention in my comment section. Thank you all.